All right, let's just jump right into this. Picture this. You're high up in the Swiss Alps, surrounded by some of the most stunning landscapes you can imagine. But what if I told you that deep inside those mountains, hidden from view, there's an engineering project so massive it's almost hard to believe? The Swiss have literally hollowed out mountains to create giant batteries. And no, I'm not talking about the kind in your phone. We're talking about something way more fundamental. Batteries powered by water and gravity itself. See, this whole massive project, it's all about solving one of the biggest headaches of our green energy future. We've gotten really good at capturing power from the sun and the wind, but the problem is these sources just don't work on our schedule. What happens when the sun sets, but millions of us are turning on our lights and cooking dinner? Our demand for electricity, well, it doesn't just stop. And this right here, this really shows you the core tension. On one side, you've got the renewable energy supply, which is kind of moody, right? It's variable, unpredictable, and totally dependent on the weather. And on the other side, you've got our grid demand, constant, predictable, always on. Managing this mismatch is this incredible high-stakes balancing act. Too much power, and you can actually crash the grid. Too little, and you get blackouts. So, here's the key takeaway. The next huge leap forward for clean energy isn't just about building more solar panels or wind turbines. It's about figuring out how to bottle that energy, how to save all that abundant solar power from the middle of the day for the evening when we all need it. We need enormous reservoirs of power. We need giant batteries. And this is where a really old, super elegant technology gets a 21st century makeover. It's called pumped storage hydropower. Seriously, forget complex chemistry. Just think of it as a water battery. The concept is so beautifully simple. It just uses two lakes at different heights to store and release energy whenever we want. Okay, so here's how it works. When the grid has way too much power, say it's a super sunny and windy day, the system uses that cheap extra electricity to pump water uphill from a low lake to a high one. That's charging the battery. Now, all that water sitting hundreds of meters higher is holding a massive amount of potential energy, like a giant coiled spring. Then, when the grid is desperate for power, they just open the gates, gravity does its thing, the water rushes back down through these huge turbines, and it generates a ton of electricity, right when we need it most. Which brings us right back to Switzerland. You know, from the surface, all you see is just pristine alpine lakes and these incredible peaks. There is almost zero indication that beneath your feet, one of the most powerful and sophisticated energy storage systems in the world is just humming away. But then you see this. This is what's really going on, hidden deep underground. It's like a vast subterranean cathedral of engineering, a whole complex of tunnels, enormous caverns, and vertical shafts bored straight through solid granite. It's an entire industrial world buried inside a mountain. The sheer scale of these projects, especially Nantes and Limernon, it's mind-boggling. We're talking about more than 17 kilometers of tunnels for just one plant. Machine halls the size of stadiums carved out 600 meters below the surface. The amount of rock they pulled out of there could bury 30 football fields. This wasn't just construction, it was modern-day mountain carving on an absolutely epic scale. And this quote just captures the human side of the challenge perfectly. This wasn't something they could just design in an office. They had to actually execute one of the most extreme construction projects ever attempted in one of the world's most beautiful and most unforgiving environments. Just stop and think about that for a second. Before you even start digging, you have this logistical nightmare. How on earth do you get thousands of tons of heavy equipment, concrete, steel, and hundreds of people to this remote, isolated spot way up in the Alps where, for the most part, roads just don't exist? Well, the solution was just as brilliant as the project itself. Instead of bringing everything up the mountain, they brought it inside the mountain. After getting initial access with these huge cableways, they carved out entire operational bases deep underground. We're talking concrete factories, workshops, even living quarters for the workers, all inside the mountain. And the excavation itself was this relentless, perfectly choreographed dance. You had hydraulic rigs drilling super precise patterns into the rock, then explosives placed with surgical accuracy, and then a perfectly timed sequence of detonations that fractured the granite exactly where they wanted it. Day after day, blast after blast, they just carved their way into the heart of the Alps. Okay, now let's talk about one of the craziest parts of this whole thing, a feat that really comes down to one number:
40 degrees. At the Limern plant, that was the angle of a pressure shaft they had to bore. I want you to imagine a tunnel, over a kilometer long, driven straight up through the mountain at a slope steeper than an expert ski run.
So, to pull this off, they needed a machine that literally did not exist. Engineers had to develop a totally one-of-a-kind 800-ton tunnel boring machine. And the secret sauce was this revolutionary safety system, a triple redundant mechanical anti-slip lock. Because, at that angle, failure is just not an option. It was a world-first solution for a world-first problem. And this is what all that incredible effort gets you. A perfect network of steel and concrete arteries, the circulatory system of the water battery. All of it engineered to handle unimaginable pressures and operate flawlessly for the next century. So what's the payoff for this insane amount of work? Let's talk power. Nant de Drans has a capacity of 900 megawatts, and Limern is at 1,000 megawatts. To give you some perspective, each one of these plants can generate as much electricity on demand as a large nuclear power station. But raw power isn't even the full story. The real magic is in the storage. The Nant de Drans plant, by itself, can hold 20 million kilowatt hours of energy in its upper reservoir. That is a vast lake of pure potential power just waiting to be unleashed. And this is why this should matter to every single one of us. 20 million kilowatt hours is a pretty abstract number, so what does it really mean? It means there's enough stored electricity in there to fully recharge the batteries of 400,000 electric cars. All of a sudden, the massive scale of this mountain battery becomes very, very real. But maybe the most critical number of all is this one: speed. The entire plant can go from storing energy to generating power at full blast in less than 5 minutes. That's like an adrenaline shot for the power grid, the ability to respond to sudden changes almost instantly. And that incredible speed is what finally solves the problem we talked about at the beginning. When a huge cloud bank suddenly covers a massive solar farm, or the wind just dies down unexpectedly. These water batteries can kick in almost instantly, fill that gap, and keep the entire European grid stable. They are the ultimate shock absorbers for a world running on clean energy. So when you just take a step back and look at the whole picture, the cost, the challenges, the absolute audacity of it all, what does this really tell us about where we're all heading? Here's the most important point. Projects like Nant de Drans, they're more than just cool engineering feats. They're a working blueprint for the future. They prove that we can build the large-scale, long-duration energy storage we need to make a grid powered 100% by renewables, not just a dream, but a practical, achievable reality. And that kind of leaves us with a really fascinating thought to chew on. This one plant stores the same amount of energy as 400,000 car batteries. But as technology keeps evolving, what happens when the millions of electric vehicles on our roads are all connected to the grid? Could they become this huge, spread-out network of tiny mobile batteries all working together? The mountain shows us the power of one giant battery, but maybe, just maybe, the future lies in the coordinated power of millions of small ones.